Hello everyone, I am Dr. Praneet. I'll be teaching chemistry today. This will be third part of the second chapter. Okay, so I'm excited to connect with you all through the Knowledge Temple, a platform dedicated purely quality education and mentorship for the student across the India. Here you'll be getting a structured learning platform, live lectures, mock tests and performance-based rewards. Today we'll be learning some interesting thing, that is the spectrum. As we know, there is a particular thing called prism. Okay, suppose this is a prism. Okay, the unique property of the prism is if we propagate a light, there is a slight diffraction and deviation into 7 colors. This is known as a spectrum of light, which is a continuous band which starts from the red and goes up to violet. You might be knowing this term Vibgyor: violet, indigo, blue, yellow, orange and red. Okay, so why we have to learn this spectrum? Okay, if there are two particular atoms, so one is in excited state and one is in a ground state. So for a particular atom to go from a ground state to an excited state, the energy should be given and it should be absorbed. So when there is an absorption of the energy, it goes from the ground state to an excited state. Similarly, if there is an atom which needs to be gone from the excited state to the ground state, the energy should be emitted. That is, emission of the energy should be seen. That is an emission of the spectrum. So spectrum for a black body spectrum is, if a black body is made incident on the prisma, we see a continuous spectrum. But if a gaseous atom spectrum, for example a hot dilute gas or some, we see a line spectrum. Okay, line spectrum, that is, it is not continuous and we see a line formation of it. Okay, so line spectrum of the hydrogen, what is exactly it of hydrogen? So hydrogen spectrum, basically it has a several series of line, that is wave number, that is V is equals to 10967 into 1 by 2 square minus 1 by n square into centimeter square. So what formula is, basically this formula is known as the Balmer's formula. Okay, here this quantity is known as the Rydberg's constant. Okay, so line spectrum is known as Rydberg formula, which is given as n. Here we know n1 and n2, here we have written as n square, right? So n1 square is basically the ground state of which the electron is present, and n2 basically the orbital to which the electron needs to be gone. Okay, so n1 for hydrogen is 1 and n2 can be n1 plus 1, n1 plus 2, and it goes on further. Okay, so here for hydrogen we can apply the number as 1. For hydrogen oxygen it will come as 2 and it will go on further. Okay, it has a series of lines, for example the Lyman series, the Balmer series, the Paschen series, the bracket series and a point series. Okay, so this is a particular diagram which needs to be learned by heart. Here they have given n1 is equals to Lyman series, n2 is equals to, here this is the Lyman series, this is the Balmer series, this is the infrared. Okay, this is the Balmer series. Okay, and this goes on further. Okay, so line spectrum they have given as n1 n2 value. The n1 for Lyman will be 1, n1 for the Balmer will be 2, n1 for Paschen will be 3, and it will go so on, and n2 will be this n1 plus 1. Okay, so here one thing should be noted down is the Balmer region is the only visible ray. Okay, this is asked as an MCQ. So let's solve the question. What is the wavelength of the light emitted when the electron of an hydrogen atom undergoes a transition from energy level 4 to 1? So one thing we should note down when such type of question comes is, first we have to observe the question. They have asked what is the wavelength. Secondly, they have given hydrogen atom. Thirdly, they have given energy levels. So while looking the things which are given, we should know which formula should be applied. So first we have to note down what is things they have given. They have given n1 is equals to 2, n2 they have given as 4, they have given as hydrogen atom. So therefore we know that Rydberg's constant is equals to 109 bracket 1 upon then comes as 2 square 4 minus 1 by 4 square 16. Okay, so wave number will be equals to 2056. So wave equals to, so lambda is equals to 1 by wave number, which comes as 486. So this was the thing that is very important to learn about the line spectrum. Okay, next thing we'll be learning about the Bohr's model for hydrogen atom. Okay, so today we'll be learning about the postulates of the Bohr's model, results obtained from the Bohr's model, explanation of the line spectrum, and the limitation of the Bohr model. Okay, so postulates of the Bohr model are general features, structure of the hydrogen atom and its spectrum is explained. Electrons revolve around the nucleus in a fixed circular path. These orbits have constant energy and radius. It removes the limitation of the collapsing electron from the Rutherford theory. Rutherford said that if it is revolving around the circular plate, the energy shrinkage and the radius also increases. Thus, the electron will remove out. Secondly, it said that the orbit of the electron does not change unless energy is added or removed. He said that the electron tend to move or revolve around a certain orbit unless and until there is any absorption of the energy or there is no removal of any energy. Okay, so when there is a gain of energy, that jumps from lower energy to higher energy. When there is a loss of energy, it jumps from higher energy to lower energy. Okay, so what are the postulates of the third postulate of the Bohr's model? It says that the frequency of the radiation emitted absorbed by an atom depends upon the energy difference between the initial and the final. That is, we know that the frequency is equals to change in the energy, that is change in final minus initial, upon this will be equals to Planck's constant. Okay, fourth one, he said that the angular momentum of the electron is quantized, that is the angular momentum is the tangential perpendicular against the momentum of the electron. So it will be equals to mass into velocity into radius equals to nh by 2 pi. Okay, let's solve the question and get things clear. Here they have asked which of the following cannot be the value of the angular momentum of an electron in hydrogen atom. So here they have given h, first is nh by 2 pi, here n is equals to 1. Second is h by 2 pi, that is n is equals to 2. Third is the nh by 4 pi, that is 3 by 2. And fourth is a 3 by 2 by, so here they have given 3 by 2. So n as in 3 by 2 cannot be possible as it is not an integer. As we have said that n is always an integer. Since 3 by 2 is not an integer, this is an answer. Now let's learn about the results obtained from this Bohr model. Okay, first was the stationary states of an electron are numbered as 1, 2 and 3. The integral numbers are known as principal quantum numbers. The radius of the stationary states are expressed as r is equals to n square E naught, where E naught is 52.9. Thirdly, the energy associated with electrons in a stationary state or orbit shell is given as E1 is equals to minus 2.18 into 10 raised to power minus 18 by 1 by 1 square joule, and E2 will be minus 2.8 into 10 raised to power minus 18. Thus the standard formula will be En is equals to minus RH 1 by n square. So the Bohr's theory is applicable to the ions containing only an electron. For example, helium has only 1 electron, lithium has only 2 plus electron, barium has 3 plus electron. Okay, the energy and radius of the stationary atom associated with these kinds of ions are given, where En is equals to minus 2.18 into 10 raised to power minus 18 into z square by n square. Z is equals to atomic number and n is equals to number of the radius orbital. Okay, so the velocities of the electron moving in a stationary orbit can be calculated as Vn is equals to 2.165 into 10 raised to power 6. That is, Vn is directly proportional to the atomic number, and Vn is inversely proportional to the Okay, so let's solve this question. What is the radius of the third orbit of an hydrogen atom? Okay, so here they have given Rn is equals to 52.9 into n square by z. So Rn is equals to 52.9 into 3 square by 1 comes to 476.1. So now let's learn about the explanation of the line spectrum of the hydrogen. So explanation of the line spectrum of the hydrogen is each spectral line, whether in absorption or emission of the spectrum, can be associated with a particular transition of the hydrogen atom. For example, delta E is equals to EF minus EI, that is minus RH upon NF square minus of minus RH upon N1 square. So here delta E is comes as 2.18 into 10 raised to the minus 18, 1 by N1 square minus 1 by NF square. So I will be the initial and F will be the final. Okay, this expression is similar as the Rydberg expression. Okay, the frequency can be found as delta change in the energy upon Planck's constant. Change in energy can be final minus initial, and the wave number can be 1 by n1 square minus 1 by n final square. Okay, in case of large number of the hydrogen atom, the different possible transition can be observed and thus leading to a large number. This is a very important point. It said that in case of large number of hydrogen atom, different possible transitions can be observed, thus leading to a large number of spectral lines. Okay, the intensity of the spectral lines depends upon the number of photons of same wavelength of frequency observed emitted. So now let's learn the limitations of the Bohr's model. There was certain limitation of this model. It did not account for the stability, the line spectra of the hydrogen atom and the hydrogen atoms like this, which was of drawbacks of the Rutherford's model. Okay, but the limitation of the Bohr's model was details of the hydrogen atom spectrum was not explained. Spectrum of atoms having more than one electron. He only explained about lithium, hydrogen, helium, but he did not explain about sodium or etc. atoms. Okay, splitting on the spectral lines in the presence of magnetic field and an electric field. Thirdly, the ability of the atoms to form molecules by chemical bonds. Okay, so this for the summary. We learned about the postulates of the Bohr's model. The angular momentum is quantized. The results obtained from the Bohr's model is Rn, En and Vn, where we can find out the radius, the energy and the velocity. Okay, also we learned about the explanation about the line spectrum, why does it occur, and the limitation of the Bohr model. Limitation of the Bohr model was the details of hydrogen only studied about atoms having only one electron, splitting of the spectral lines in presence of magnetic field and electric field, and ability of the atom to form the molecules of the chemical bonds. Okay, so this is one of the most important topic which can be asked as a long answer question. Also MCQs can be expected from this topic. Okay, I hope you like this lecture. If you like it, you can join the Knowledge Temple for complete learning, live classes and mentorship. Together, let's make the learning engaging and rewarding. Thank you.